Welcome back to Math 107 College Algebra. In this video, we're going to take a look at solving a system of equations using an augmented matrix. So here I've given you a system of equations. X minus 2y plus 3z is equal to 4. 2x minus y plus 4z minus 1 is equal to negative 1. And x minus y plus z is equal to negative 3. So first we're going to set up the augmented matrix. We're simply going to put the coefficients on x, y, and z in that order. So we have then we're going to draw a vertical line, and on the right side of that line we're going to put the constants that these are equal to. And now we're going to go ahead and set up, or start working the problem. So we can almost think of this as a game, and there's 3 different moves that we can make. One, we can swap 2 rows. So we decide maybe we want to switch the first row and the third row or something like that. We can do that. Second thing we can do is multiply a row by a non-zero constant. And third thing we can do is add a multiple of a row to another row. And our goal is to have a matrix in the end where the first entry in each row is a 1, or first non-zero entry. And that 1 is going to have zeros above and below it. So maybe we have a situation that got a couple zeros in there before our first one. So we'll have a non-zero there. So that one's going to have zeros above and below it. And then maybe we have a situation here so we might get a matrix looking like that. The idea is we want the first non-zero entry in each row to be 1. And above and below that 1, we want zeros. So I'll get rid of that. So the first thing that I'm going to do is add negative 2 times the first row to the second row. We're going to start in the first column, make everything below that 1 on top a 0. So adding negative 2 times the first row to the second row. The first row stays the same. And then the second row, adding negative 2 times the entry that's in the top row. So I get 0. And then negative 2 times negative 2 is positive 4 minus 1 gives me a positive 3. Negative 2 times 3 is negative 6, plus 4 gives me negative 2. Negative 2 times 4 is negative 8, minus 1 gives me minus 9. And the third row is going to stay the same for now. Now in the next step, I'm going to subtract the first row from the third row, or add -1 times the first row to the third row. So in doing that, the first two rows stay the same. And then subtracting the first row from the third row, I get a 0 there. -1 plus 2 gives me a +1. And 1 minus 3 gives me -2. And -3 minus 4 gives me -7. So now, because of the fact that I want the first non-zero entry in the second row to be 1, I have the convenient thing that the third row has its first non-zero entry as 1. So here I'm going to go ahead and swap the second and third rows. So 1 minus 2, 3, 4 in the first row. Now the second row is going to become what the third row was. So 0, 1, minus 2, minus 7. And the third row will be 0, 3, minus 2, minus 9. And now my next step is I'm going to add 2 times the second row to the first row. So in doing that, I have 1 and 2 times the second row. 2 times 1 is 2, minus 2 gives me 0. 2 times minus 2 is minus 4, plus 3 gives me minus 1. 2 times minus 7 gives me minus 14, plus 4 gives me minus 10. And then the second and third rows stay the same. And now for my next step, I'm going to add -3 times the second row to the third row. So 0, -3 times 1 is -3, plus 3 gives me 0. -3 times 2 is +6. Minus 2 gives me 4. -3 times -7 gives me a +21. Minus 9 gives me 12. So now I want to make that first non-zero entry 1. So I'm going to go ahead and multiply the third row by 1/4. And now I'm going to add twice the third row to the second row. So 1, 0, minus 1, minus 10. First row stays the same. Then adding twice the second row, or third row to the second row. Still get 0, 1. And then 2 times 1 is 2, minus 2 gives me 0. 2 times 3 is 6, minus 7 gives me -1. And then third row stays the same. And now I'm going to add the third row to the first row. So in doing that, I get 1, 0. -1 plus 1 is 0. 3 minus 10 gives me -7. Then the second and third rows stay the same, if I can write them correctly. And now is the point that I can just read off my answers from that matrix. So I have x equals -7, y equals -1, and z equals 3, which we can write as the ordered triple, -7, -1, 3. So that's how we solve a system of equations using an augmented matrix. In the next set of videos, we're going to take a look at a different way that we can use matrices to solve linear equation, or systems of linear equations. So with that, I will see you guys on Wednesday.